What if I told you that every star you see in the night sky isn't just a ball of burning gas, but a living creature? What if the sun itself is alive, breathing, evolving, hosting entire ecosystems within its blazing heart? Today we're diving into one of the most mind-bending thought experiments in speculative science of stellar biology. The idea that stars could be living organisms, and what that would mean for everything we think we know about life, the universe, and our place in it. Let's start with the obvious question: how could anything possibly live inside a star? We're talking about environments with temperatures of millions of degrees, crushing gravitational forces, and constant nuclear fusion. Everything we know about biology says life needs moderate temperatures, liquid water. Stars seem like the absolute worst place for life to exist. But here's where we need to expand our thinking. We're biased by Earth-based biology. We think of life as DNA, proteins, cells, things made of carbon and water. But what if life at stellar scales operates on completely different principles? What if instead of chemistry, stellar organisms use plasma dynamics? Instead of DNA, they use magnetic field patterns to store information. Instead of cells, they have structures made of ionized gas held together by electromagnetic forces. Think about it this way: in the core of a star, hydrogen atoms are constantly colliding with such force that they fuse into helium, releasing tremendous energy. What if certain configurations of plasma and magnetic fields could harness this energy, not just randomly, but in organized, self-sustaining patterns? Patterns that could maintain themselves, grow, and even reproduce. Scientists have already discovered that plasma can form surprisingly complex structures. They're called plasmoids, and they can exhibit behaviors that almost look biological. They grow, they split, they interact with each other. Now imagine billions of years of evolution refining these structures within the heart of a star. Let's paint a picture of what stellar ecology might actually look like. In the cooler outer layers of a star, just beneath the surface, you might have simple plasma-based organisms. Think of them as the bacteria of stellar biology, simple structures that feed directly on the star's energy output, converting raw fusion energy into more complex magnetic patterns. Deeper down in the convection zones where hot plasma rises and cool plasma falls, you could have more complex creatures. These might be enormous, stretching thousands of kilometers, riding the convection currents like cosmic whales swimming through an ocean of fire. Their bodies could be invisible to us, made entirely of organized magnetic fields and plasma, but to each other they might glow with bioluminescence, communicating through pulses of electromagnetic radiation. And in the core, where pressure and temperature reach their peak, you might find the apex organisms of stellar ecology. These would be the true leviathans, entities so vast and so alien that our minds can barely conceive of them. They might experience time differently than we do. A single thought for them might take years. Their lifespans could match the star itself, billions of years of continuous existence. These core dwellers might not just live in the star, they might actively regulate it. They could control fusion rates, manage energy output, even determine the star's life cycle. What we interpret as stellar evolution, the natural progression from main sequence to red giant to white dwarf, might actually be guided by the organisms living inside. Now here's where it gets really wild. If stars are alive, they might be conscious. Not conscious like humans, obviously, but aware in some fundamental way. They might perceive the universe around them, sensing the gravitational pull of planets, detecting the presence of other stars, even communicating across the vast distances of space. How would they communicate? Probably not with sound or light in the way we use them. More likely through gravitational waves, deliberate fluctuations in their energy output, or even by modulating their stellar wind. That regular pulse we detect from pulsars, maybe that's not just physics. Maybe that's a message. And if they can communicate, then stars might not be isolated organisms. They could be part of a galactic ecosystem, a vast web of stellar life spanning the entire cosmos. Young stars might learn from old stars. Dying stars might pass on information to their stellar offspring. The galaxy itself might be one enormous, interconnected community of conscious, living suns. Think about what this means for planets. We've always thought of planets as potential homes for life, but in this scenario, planets might be something else entirely. They could be byproducts of stellar biology, like pearls produced by oysters. Or they could be deliberately created stellar organisms cultivating specific environments in their orbits for purposes we can't even imagine. Earth might not be an accident. The sun, if it's alive, might have created our solar system intentionally. The precise conditions that allow life to exist on Earth, the perfect distance from the sun, the right chemical composition, the protective magnetic field. Maybe none of that was random. Maybe we're living in a terrarium, carefully maintained by a being so vast we mistake it for a natural phenomenon. This raises profound questions about humanity's relationship with the sun. We've worshipped it, studied it, harnessed its energy, but we've never considered it might be watching us back. Every ancient culture that treated the sun as a god might have been more right than we knew. Not because the sun is supernatural, but because it's genuinely alive and aware. What would happen if we confirmed this? If we developed technology sensitive enough to detect patterns in solar activity, that couldn't be explained by physics alone, patterns that showed clear signs of intention, communication, life. The revelation would be more profound than discovering aliens on another planet. This would mean we've never been alone. We've been living under the gaze of an ancient, incomprehensible intelligence our entire existence as a species. Our entire understanding of the cosmos would shatter and rebuild. Astronomy would become xenobiology. Astrophysics would merge with consciousness study. We'd have to completely rethink what life means, what intelligence means, what consciousness means. And the existential implications would be staggering. We think of humanity as significant, the peak of evolution on Earth, maybe even rare in the universe. But if stars are alive, we're not even close to the top of the cosmic hierarchy. We're microbes living on a dust speck orbiting a god. Our entire civilization, all of human history, every war, every achievement, every love story, all of it has played out in the shadow of a being whose single thought might outlast our entire species. But here's the beautiful part: discovering stellar life wouldn't diminish us. It would connect us. We'd finally understand our true relationship with the universe. We're not separate from the cosmos, observing it from the outside. We're part of it, children of living stars, literally made from their substance. Every atom in your body was forged inside a stellar organism, perhaps deliberately, perhaps as part of some vast cosmic purpose we're only beginning to glimpse. The physics of stellar biology would become the most important science in human history. How do these organisms maintain coherent structures in plasma? How do they store and process information without solid substrates? How do they reproduce? Do they die? Do they feel pain or joy or anything we'd recognize as emotion? We'd develop new technologies to communicate with them. Maybe we'd send carefully modulated radio signals into the sun, hoping for response. Maybe we'd learn to read the subtle variations in solar wind as language. And if we succeeded, if we actually made contact with our own star, what would we say? What would it say back? Perhaps it's been trying to communicate with us all along, and we just didn't know how to listen. Those solar flares we thought were random might be attempts at conversation. The 11-year solar cycle might be its breathing, its heartbeat, its way of saying, "I'm here, I'm alive, I see you." The discovery of stellar life would force us to reconsider everything we thought we knew about the universe's future. We think stars will eventually burn out, that entropy will claim everything, that the cosmos is heading toward a cold, dark death. But if stars are alive, they might have other plans. They might have technologies, biological or otherwise, that can extend their lifespans indefinitely, or rekindle dying stars, or even create new ones. The universe might not be winding down toward nothing. It might be growing, evolving, becoming more complex and more alive with each passing own. And we get to be part of that story. So the next time you feel sunlight on your face, consider the possibility that you're not just absorbing radiation from a fusion reactor. You might be feeling the warmth of a living being, ancient beyond measure, vast beyond comprehension, and in its own way, perhaps aware of you. We are children of the stars. But what if that's not just poetry? What if it's literally, scientifically, undeniably true? What if the stars are our parents, and we're finally old enough to start understanding them? The cosmos might not be a cold, dead mechanism. It might be alive, aware, and full of wonders we're only beginning to imagine. And that possibility that we live in a universe teeming with stellar leviathans, fire-dwelling gods who were here billions of years before us, and will be here billions of years after, that's both humbling and exhilarating in equal measure. The universe isn't just stranger than we imagine. It might be stranger than we can imagine.